No one saw this coming. Not Wall Street. Not Toyota. Not even Tesla's own engineers were ready for how fast this would move. Elon Musk just dropped a bombshell that has the entire EV world in freefall. A real, working solid-state battery, with 1,000 miles of range, and full charge, in just 5 minutes. No lithium bottleneck. No cobalt dependencies. No compromise. This isn't a lab demo. It's already rolling off Tesla's pilot lines in Giga, Nevada, and it's heading straight for full-scale production. Starting with a compact Tesla under $30,000 that may outsell every other EV ever made. Panasonic scrambling. Ford stalling. Legacy automakers just lost $46 billion in market value in 3 days. And battery startups? Left in the dust. Because this isn't just about range, it's about control. Infrastructure. Speed. Affordability. And freedom from lithium chaos. Elon Musk didn't just change the car. He may have just rewritten the rules for everything powered by a battery. Cars, planes, homes, grids, satellites. All of it. Solid state was supposed to be decades away. But Tesla made it real. Now. At scale. And this time, it's not just a step forward. It's a leap that no one can afford to ignore. If you're ready to see what this means for the future of energy, smash that like button, subscribe for more breakthroughs, and drop a comment below. Is this the moment Tesla truly leaves everyone behind? 4 years, the battery world was stuck in a lithium prison. Everyone knew lithium-ion cells were powerful, but everyone also knew they came with brutal compromises. Flammable electrolytes, limited range, slow charging, and a ticking fire hazard. The big question was, who would break free first? Then, out of the blue, Tesla flipped the script entirely. No flashy unveilings. No viral social media countdowns. No Hollywood-style product launches. Instead, behind locked doors and sworn secrecy, Tesla dropped the mother of all bombshells. At a hush-hush investor event, closed to media and public eyes, Elon Musk and his team quietly confirmed what industry insiders have only dared whisper about. Solid-state batteries are not just coming, they're already here. We're talking about battery cells that have been rigorously tested inside Tesla labs for over 18 months, powering prototype packs with performance levels that were once deemed science fiction. The headline was seismic, 1,000 miles on a single charge. Not a best-case scenario, not a theoretical target, but a verified milestone. And get this, these batteries can recharge in under 5 minutes. That's right. The same battery technology that will let you drive coast to coast on a single fill-up will also recharge faster than it takes to brew a cup of coffee. Tesla didn't reveal a new car that day, but that didn't matter. They showed something far more powerful, a working battery cell that silently obliterates every limitation holding back electric vehicles today. Elon Musk called it the final piece of the EV puzzle, and with just those words, he reshaped the entire electric vehicle landscape overnight. The media scrambled, trying to decipher a single leaked slide titled boldly, "Beyond Lithium." Because this is exactly what it means. The lithium-ion era, which has powered every phone, laptop, and EV for the past 2 decades, is ending. Tesla has rewritten the battery blueprint, and nothing will ever be the same. So what makes this breakthrough so monumental? First off, Tesla ripped out the dangerous liquid electrolytes that have been the Achilles heel of lithium-ion batteries. Instead of a flammable, volatile liquid, the new battery employs a solid ceramic polymer blend that's stable, safe, and powerful. Energy density has nearly doubled, jumping from about 250 Wh/kg in today's best cells to an astounding 450 Wh/kg. Imagine squeezing twice the power into the same size battery, and with less weight. This means lighter vehicles, longer range, and better performance. Tesla's new battery cells are 30% lighter and 15% smaller than the current Model Y S2170 cells. But it's not just about fitting more power into less space. The solid-state battery is also structurally stiffer, making the battery pack a part of the car's frame, improving rigidity and safety. Inside these cells, a secret weapon awaits. A graphene-enhanced anode that almost completely eliminates dendrite formation, the microscopic, needle-like growths that cause battery failures and fires in traditional lithium-ion packs. Tesla's internal testing has pushed these cells through more than 2,500 full charge-discharge cycles with under 8% degradation, an incredible lifespan that could translate to over 1 million miles of driving without a serious drop in capacity. And there's more. The solid-state design runs cool, really cool, even under intense charging and discharging, preventing the dangerous thermal runaway that can turn batteries into fire hazards. The revolution doesn't stop at the battery cell. Tesla has also reimagined charging infrastructure from the ground up, introducing the Gen 5 supercharger, a beast capable of pumping an eye-watering 2.2 megawatts of power through a liquid-cooled cable system. That's not just fast charging. That's raw, industrial-grade energy transfer. With this technology, Tesla owners can plug in and be fully charged in under 5 minutes. No more 15 or 20-minute stops. This is a lightning-fast turnaround that makes EVs as convenient as gasoline cars, if not more so. The catch? The power grid isn't yet ready to deliver these astronomical energy spikes at every charging station. But Tesla's solution is genius. Every Gen 5 supercharger will be paired with on-site megapacks, gigantic stationary battery systems that slowly recharge from the grid and then unleash stored energy in a massive burst when a car needs it. This means no strain on local utilities, no blackouts, and charging speeds that outpace anything else in the world. Tesla isn't just racing ahead with batteries. They're rewriting the entire charging ecosystem to unlock the full potential of their new technology. Safety, a critical factor in battery tech, has also been revolutionized. The solid-state cells are not just better performing. They are far safer than anything on the market today. They withstand extreme temperature swings from -30 degrees Celsius to 90 degrees Celsius without swelling, leaking, or failure. Puncture tests that would cause traditional lithium-ion packs to ignite or explode leave these solid batteries completely intact. Tesla took this further, crash-testing prototype battery packs inside modified Model 3 chassis following NHTSA protocols. The results? 92% less heat propagation during simulated fires compared to lithium-ion packs. The solid-state battery acts almost like a shield within the car, a load-bearing element that improves the vehicle's structural integrity, adding a new layer of crash safety. This is no longer just an energy source, it's an impenetrable fortress. Tesla has weaponized battery safety in a way that will redefine the standards of electric vehicles, and possibly all future battery-powered tech. This is not just hype or speculation. Tesla's quiet revolution inside its battery labs has laid the groundwork for an industry upheaval that will ripple through automakers, energy providers, and raw material suppliers. The solid-state battery breakthrough promises to crush range anxiety, eradicate long charging times, and deliver safety levels previously thought impossible. It is the power to drive 1,000 miles, recharge in 5 minutes, and do it all while riding on a battery pack that weighs less, lasts longer, and doesn't catch fire. Tesla didn't just announce a new battery, they announced a new era. And if you thought the electric vehicle race was close before, think again. The moment Tesla's solid-state battery went public, even just in whispers, the ripple effect turned into a shockwave. Behind the scenes, entire companies went into panic mode. At Panasonic, alarm bells rang, but not out of fear. They were already inside the storm. Weeks before the reveal, they had signed onto a joint pilot production line with Tesla inside Giga, Nevada. Quietly, strategically. This wasn't a supplier-client relationship anymore. It was a high-stakes alliance. Meanwhile, in China, CATL, the world's largest battery manufacturer, scrambled. Board meetings went into overdrive. Their executive team requested immediate regulatory consultations to update their entire solid-state roadmap. It wasn't about catching up. It was about survival. Because the timeline had just been redrawn, and they weren't on it. Across the Pacific, GM hit pause. Quietly, urgently. Their much-touted Ultium platform, the backbone of their electric future, was suddenly in question. Engineers were pulled into crash assessments. Lawyers pored over Tesla's ceramic electrolyte patents. Every blueprint was under review. Toyota? Their world-leading 2027 solid-state EV target, once a proud industry benchmark, now looked like an old newspaper headline. Tesla's breakthrough didn't just outpace it, it made it irrelevant. In just 48 hours, analyst reports shifted from confidence to panic. Banks and tech firms that once projected Tesla's tech lead as 2 years suddenly upgraded that estimate to 6, maybe 7 years, and even that felt optimistic. Because unlike the others, Tesla wasn't making promises. They were delivering. And while the competition was still issuing press releases, Tesla was testing in silence. Not in labs. Not in simulations. But on the road. In motion. Globally. 48 Tesla vehicles, equipped with solid-state battery packs, have been operating quietly across North America, Europe, and China. These aren't showroom models or demo units. They are part of a stealth data-gathering fleet, cloaked under commercial NDAs, camouflaged to look like everyday Teslas. But under the hood, history is being written. These vehicles aren't just proving range, they're validating durability, performance under extreme climates, and fast-charging stress. Engineers are watching degradation curves, analyzing cycle retention, and recording cold weather behavior in places where lithium cells normally falter. And the early results? Devastating. On average, the test vehicles are logging 965 miles per charge in real-world, mixed-condition driving, without a single stop at a charging station. And Tesla isn't sitting on the data. They've already scheduled a public release for Q1 next year. If the published numbers even come close to the internal metrics, it won't just be news, it will be a reckoning. Because real-world validation is the line no competitor has crossed. Tesla just walked right over it. But this story doesn't end with cars. Because Elon Musk didn't build Tesla to make electric vehicles. He built it to redefine energy itself. And now, that promise is expanding, beyond wheels, beyond highways, straight into the grid. Starting 2026, Tesla will begin integrating solid-state cells into its Powerwalls and Megapacks. The result? Energy storage systems that are lighter, cooler, and fully stackable, slashing installation costs by 18% and doubling operational lifespan. This means homes that once stored solar power for a day can now store it for nearly 2 full days, without needing bulky infrastructure or expensive add-ons. And in the most remote places on Earth, villages in Alaska, outposts in Australia, islands disconnected from traditional grids, Tesla's new battery units will power off-grid pilots that rely 100% on renewable energy, with solid-state packs that recharge in under 2 hours from direct solar input. This isn't theoretical. Construction has already begun. These aren't just home upgrades, they're energy liberation systems for the edge of civilization. And they're built using the same battery platform that's powering the next generation of vehicles. Tesla's energy division and automotive division, now running on the same fuel. And here's the part that will send shockwaves through global markets. This new battery doesn't just work better, it's built smarter. The supply chain for Tesla's solid-state tech is like nothing the world has seen. The battery uses no cobalt, no nickel, and less than 5% lithium by mass. That alone eliminates the geopolitical powder keg around mining and trade dependencies. The ceramic electrolyte, made from a lithium phosphate oxide blend, is not only non-toxic and inert, but also scalable within Tesla's existing gigafactory production lines. No need to reinvent the machinery. Just update the inputs. And those inputs? They come from home turf. With most materials sourced from North America, Tesla has successfully bypassed the critical mineral choke points that have plagued other automakers. No more waiting on cobalt from the Congo. No more nickel from Indonesia. No more rare earth drama from overseas. To tighten the loop even further, Tesla has built a brand new anode manufacturing facility in Texas, cutting shipping costs by over 40% and slashing delays from global freight bottlenecks. This is vertical integration on steroids. It's not just batteries made in America. It's entire battery ecosystems, grown from scratch on domestic soil. By 2027, Tesla aims to produce 80% of solid-state battery components entirely in-house, creating what analysts are already calling the most secure and scalable energy platform in the Western world. And if that goal is met, Tesla won't just be a car company. It'll be a sovereign energy power. But vision means nothing without execution. And while critics were still drafting white papers, Tesla was already pushing electrons through ceramic cells, at scale. While the world was still catching its breath, Tesla was already ramping. 2 pilot solid-state lines had quietly gone live inside Giga, Nevada, fully operational, shockingly efficient. The initial production capacity? 250,000 packs annually. Not prototypes. Not concept cells. Real packs. Ready to be installed. And here's the twist. Tesla's internal yield rate on these next-gen cells had hit 91%. That's not lab grade, it's production grade. No one else had even cleared 70%. Then came the automation. Full-scale robotic handling of ceramic electrolyte sheets, zero moisture contamination, sealed lines running on AI-monitored feedback loops. The result? Labor costs slashed by 60% per pack. Human error eliminated. Speed doubled. It wasn't just manufacturing, it was surgical precision at industrial scale. And this was just Nevada. Next stop? Giga, Mexico. Still under construction, but already redesigned from the ground up for solid-state only manufacturing. No hybrid lines. No legacy lithium-ion stations. Just clean sheet engineering for a new battery age. And by 2026, Mexico will roll out the first ever Tesla with zero liquid electrolyte and 100% ceramic architecture. That car isn't theoretical anymore. It has a name. Codenamed Model Q, it's not just another crossover. It's the first ground-up solid-state Tesla in history. And everything about it breaks the rules. 1,000 miles of real-world range. 5 minutes to full charge. Under 30 grand. That's not evolution. That's combustion engine extinction in disguise. Model Q uses Tesla's new cell-to-body structural pack integration, turning the battery into part of the chassis. That means no dead weight, no excess metal. The entire platform? 28% lighter than a Model Y, and yet stronger. More rigid. Safer. And because it's designed for mass production from day one, Tesla expects it to become their best-selling vehicle of all time. Yes, even bigger than the Model 3. But while Tesla moved forward, the rest of the industry started crumbling. Legacy automakers, who spent years retrofitting factories around lithium-ion, now faced the grim math of irrelevance. Billions sunk into gigafactories suddenly looked like dead ends. GM reportedly paused its entire Ultium expansion. Toyota's solid-state roadmap, once the pride of its R&D division, was now called late and underpowered by its own engineers. Battery giants like LG, Panasonic, and SK On began scrambling. Licensing negotiations with Tesla's legal team were underway within days, especially for the ceramic electrolyte patent, the one they said wasn't even possible in a stable, scalable format. Now, they wanted in. But the cost? Rumored to be north of $4 billion just for a basic use agreement. Tesla wasn't handing out lifelines. It was pulling up the ladder. And then came the market shock. Over $46 billion was erased from legacy EV and battery stocks in just 3 trading days. Startups who promised next-gen chemistry found their pitches suddenly obsolete. Silicon anode companies, sodium-ion developers, lithium-air dreamers, gone from front-page headlines to footnotes. One analyst wrote, "It's not a tech race anymore. It's cleanup." Elon Musk, never one to miss a moment, tweeted a single sentence that sent shockwaves through investor circles. This wasn't just about range. It was about ending compromise. And that's exactly what it was. Because this new battery didn't just improve on old ideas, it erased the need for them. Charging stations? Less relevant when you can fill up in 5 minutes. Battery degradation fears? Gone. Environmental concerns over cobalt mining? Eliminated. Global supply chains stretched across 4 continents, replaced with domestic factories powered by solar and wind. Tesla didn't just reinvent the battery. It changed the economics of mobility. It collapsed timelines, defied predictions, and broke through the ceiling everyone thought was 5 years too thick to penetrate. And now, with solid-state technology fully integrated into Powerwalls, megapacks, and soon even aviation prototypes, the future looks rewritten. Because this battery isn't confined to cars. Imagine a grid-scale megapack that recharges in under 2 hours using only solar panels. Imagine rural villages in Alaska running power 24/7 without diesel. Picture container ships crossing oceans on zero emissions. Or rockets landing with power systems that weigh 40% less. This isn't hypothetical. It's already being tested behind closed doors. Even aerospace insiders have taken notice. Reports from insiders at SpaceX suggest the ceramic cell derivative tech is being evaluated for future missions, especially where weight-to-energy ratio is critical. Satellites, drones, even long-range aircraft, they're all potential platforms for this battery revolution. And it all started with a single decision: to throw out the rulebook and build something that wasn't supposed to exist until 2035. But Tesla didn't wait for the future. It brought it forward a decade. The auto industry is no longer just about horsepower, or torque, or luxury interiors. It's about storage density, charge kinetics, grid interface. Whoever owns the battery owns the future. And right now, Tesla isn't just in the lead. It's running uncontested. The era of lithium is over. The age of solid state has begun. And as always, Elon Musk didn't follow the trend. He changed the playbook. So if this left you speechless too, hit that like button to help this reach more people. Subscribe to stay ahead of the next big shockwave, and drop a comment, because the next Tesla announcement might make this one look small.